Welcome to Math Simplified. This video is for 9th standard students. We are studying the 4th chapter, Geometry. Exercise is 4.4. The topic today is Cyclic Quadrilaterals. Please subscribe and share with your friends also. Question 1. Find the value of x in the given figure. So this is a circle and this is a cyclic quadrilateral within the circle. Okay. The rule for cyclic quadrilaterals is that the sum of the opposite angles is equal to 180. That means angle D plus angle B is equal to 180. Angle A plus angle C is equal to 180. Okay. In this sum, they have given us the value of angle D and they are asking us to find the value of x here. That is angle CAB. Okay. So, by the rule of cyclic quadrilaterals, we know that angle D plus angle B is equal to 180. Therefore, angle B is equal to 180 minus 120. That is 60 degrees. So, this angle is 60 degrees. Now, take the triangle ACB. This triangle, okay, this is the diameter. The angle opposite to the diameter is always 90 degree. Always remember that. Okay, so in this triangle, the sum of all the three angles will be equal to 180. So x plus 90 plus 60, which we found just now, plus 60 is equal to 180. Therefore, x is equal to 180 minus 90 minus 60, that is equal to 30. So, two rules we have applied in this sum. The first one is the sum of the opposite angles of a cyclic quadrilateral is 180. Second rule is that the angle opposite to the diameter of a circle is always 90 degree. Okay. Second sum. In the given figure, AC is the diameter of the circle with center O. If ADE is 30, so here they have given us this angle as 30, this angle DAC as 35, CAB as 40. They are asking us to find these three angles. Okay, let's take the first one. ACD. ACD. This angle we have to find. Okay, take the triangle DAC. This triangle, okay, this is the diameter of the circle. Therefore, the angle opposite to this angle ADC is 90 degree, okay, and we have to find this angle. So, this angle is equal to 180 minus 90 minus 35. That is equal to 55 degrees, okay. Next one is ACB. That is ACB. This angle we have to find. This angle, again, take this triangle ACB. This is the diameter. The angle opposite is angle B. This angle is 90 degree. So, this angle ACB is equal to 180 minus 90 minus 40. That will give us 50 degrees is this angle. The third is DAE. DAE. Okay. This angle we have to find. So take this cyclic quadrilateral AEDC. Okay. This quadrilateral. Okay. The opposite angles, the sum of the opposite angle is equal to 180. That means this angle plus 35 plus 30 plus 90. We already know this angle is 90. Plus 90 is equal to 180. See here, all these four angles, this angle plus 30 plus this angle is equal to 180. So, this angle, the required angle is equal to 180 minus 155. That is equal to 25. Okay. Find all the angles of the given cyclic quadrilateral ABCD. So, this is the quadrilateral. Cyclic quadrilateral, we have to find these angles, four angles. So, you know that angle D plus angle B is equal to 180. So, 7x plus 2 plus 6x minus 4 is equal to 180. See here I've written it. So if you simplify this, you'll get 13x is equal to 182, that is x is equal to 14. Substitute this value of x here, you'll get angle D is equal to 100, and here substitute, you will get angle B as 80 degree. Okay. Now for angle A and C, add these two angles, that is equal to 180. Simplify, you'll get the value of y as 30. Substitute y here, you'll get angle A as 64. Substitute y is equal to 30 here, you'll get angle C as 116. So these are the four angles. So in the sum, what we have done is this plus this is equal to 180. Found the value of x and substituted, we got the angles. Similarly, this plus this is equal to 180. Found the value of y and substituted it again. Question 4. In the given figure, ABCD is a cyclic quadrilateral where diagonals intersect at P such that DBC is equal to 40 and BAC is equal to 60. So this is a cyclic quadrilateral and these two angles have been given. We are asked to find CAD. That is this angle, CAD. Okay. Now if we consider this as the base here, this line segment, it subtends angle 40 degree at point B, and this angle 40 degree, it will subtend at any point on the circle. Okay, this base, this line segment. Okay, so you can see that A is one such point. Here at this point, this base will subtend an angle of 40 degree. So the angle CAD is equal to 40. Okay. Now they are asking us to find the value of BCD. BCD, this angle. Okay. So this is a cyclic quadrilateral. So the sum of the opposite angles will be equal to 180. So DAC plus CAB plus BCD is equal to 180. This is 40. This is 60. So 100. So this angle is 180 minus 100. That is equal to 80 degrees. Question 5. In the given figure, AB and CD are the parallel chords of a circle with center O such that AB is equal to 8 cm, CD is equal to 6 cm. If OM is perpendicular to AB and OL is perpendicular to CD and the distance LM is 7 cm, find the radius of the circle. So, okay. So these are two parallel chords. The length of this chord is 8 cm. The length of this chord is 6 cm. This is a perpendicular. Okay. They are asking us to find the radius of the circle. This is the radius. OB is the radius. Okay. So this distance between the two chords is 7. Supposing I take OM as x, this distance OL will be 7 minus x. Is it not? So OM, let OM be x. So OL will be 7 minus x. Okay. MB will be what? It will be 8 upon 2, that is 4. So take this triangle. We know that MB is 4, OM is x, and OB we do not know. We have to find. That's the radius. By Pythagoras theorem, OB square is equal to 4 square plus x square. That is the first equation. 4 square is 16. 16 plus x square. This is OB square. Similarly, take this triangle and write down OD square. OD square is, what is this? 7 minus x. 7 minus x the whole square plus this distance LD is 3. So 3 square. So here it is 3 square plus 7 minus x the whole square. Simplify it and you will get this expression. Now put both are equal. OB is equal to OD. Okay. So put this equation as equal to this equation and simplify. You will get the value of x as 3. Now you substitute x as 3 in this equation and you simplify it. You will get OB square as 25. So OB is 5 centimeter. So this distance OB, the radius, is 5 centimeter. Again, I repeat what I have done. These are the two parallel chords. So this distance MB is 8 upon 2. This is 4. I've taken OM as x. OB square is equal to x square plus 4 square. That is the first equation. Second is OD square is equal to 7 minus x the whole square plus 3 square. And both are equal. OB square is equal to OD square. So I put those two equations as equal, simplified it, found the value of x, substituted x again in the first equation, and I got the distance OB, or the radius. Question 6. The arch of a bridge has dimensions as shown, where the arch measures 2 meters at the highest point and its width is 6 meters. What is the radius of the circle that contains the arch? So here is the arch. The height of this arch is 2 meters. The width of the arch is 6 meters. Okay. We have to find the radius of the circle which contains this arch. Okay. Let O be the center of that circle which contains the arch. So what is the radius? OB is equal to OC. See, this is the center of the circle. So OC is equal to OA. Let it be R. Okay, now look at this triangle. Okay, what is this distance? DO. It will be radius. This whole distance is R. R minus 2 is DO. So this is R minus 2. This distance will be 6 upon 2, that is 3. Okay, so this is R, radius of the circle. R square is equal to R minus 2 the whole square plus 3 square. See, here I have written R square is equal to R minus 2 the whole square plus 3 square. So simplify this, you get the value of R as 13 upon 4 is equal to 3.25 meters. Here in figure, angle ABC is equal to 120, where ABC are points on the circle with center O. Find OAC. So this angle we are supposed to find. Okay. So here, this the last exercise we learnt about the angle subtended at the center by an arc. Is it not? That it is double the angle subtended at any point on the circle. So this angle here, it is subtended by this arc at the center. This will be double this angle. So this will be 240 degree. This angle is given as 120. So this will be 240. Okay. So what will be this angle? Angle AOC, 360 minus 240. So this angle is 120. Okay. Consider this triangle. Okay. So this is an isosceles triangle. So this angle OAC is equal to OCA. And this angle is 120. So 120 plus 2 times OAC is equal to 180. Because the sum of all the angles is equal to 180. Okay. So I get this equation. Simplify this. 2 times OAC is equal to 60 degree. OAC is equal to 30 degree. Okay, so what we have done by the first rule, we have found out this angle. Okay, 360 minus 240. Once we found out this angle, we have applied that rule that the sum of all three angles is equal to 180 and simplified. Question 8. A school wants to conduct a tree plantation program. For this, a teacher allotted a circle of radius 6 meters to 9th standard students. So here is the circle, that is the ground allotted to the students. The radius of the circle is 6 centimeters. So, sorry, meters. It is meter. Okay. Then what happens? 4 students plant at points A, B, C, D at points shown. So here 4 students, they have done a tree planting. One here, A, B, C, D. Okay. Here AB is 8 meters. So they have given this length as 8 meters. So at this midpoint, it will be 4 meters distance. Similarly, if you take the midpoint on this, this will be 5 meters. Okay. And AB perpendicular to CD. So these two are perpendicular lines. So this angle will be 90 degree. If another student places a flower pot at point P, so at the point of intersection, there is a flower pot here. Find the distance from the center to P. So this distance we have to find. Okay, so you have drawn this diagram on the basis of all these statements. So here we can see this is the radius of the circle. Okay, and these are the two lines which intersect at 90 degree. Okay, now let us draw a perpendicular line to this. Okay, this point is the midpoint M, and this is the midpoint of this N. So this distance becomes 8 upon 2, that is 4, and this distance ND is 10 upon 2, that is 5. Okay, let's take this triangle AMO. This distance MO is equal to square root of 6 square minus 4 square by Pythagoras theorem. Okay, simplify it, you get root 20. Okay, similarly find the length ON of this triangle. So here also this is the hypotenuse. So this distance will be ON is equal to square root of 6 square minus 5 square. See here, 6 square minus 5 square, that is equal to 11. So NO, this distance is equal to square root of 11. Okay, now you have to take this triangle, this small triangle MOP. This also is a right angle triangle because this angle is 90 degree. Okay, so this is the hypotenuse which we have to find, OP. OP square is equal to MO square plus MP square. MO square we found MO as root 20. So write down here, it will become 20. MO square will become 20. Okay, plus MP. MP is equal to NO. Is it not? The same distance. We found NO as root 11. Substitute here. Simplify it. You get OP square is equal to 31. So OP is equal to square root 31. That is equal to 5.6 meter. So important thing is that with these statements, you should draw the figure. And once you draw the figure correctly, you can easily take these triangles and apply Pythagoras theorem and solve it. In the given figure, POQ is equal to 100 degrees and PQR is equal to 30 degrees. Then find RPO. So here we have to find RPO, this angle. They have given this angle O as 100 and angle RQP, this angle as 30 degree. Okay. So here again, this is the base. This is the angle subtended at the center, and this angle is subtended at any point, this point R on the circle. Okay, so this value of this angle is equal to 100 upon 2, that is 50. Okay, all these rules we did in detail in the previous exercise 4.3. Please go through that. Okay, so this angle becomes 100 upon 2, that is 50 degree. Okay, now we'll take the small triangle OPQ. Okay, so here we can see that the sum of all the angles will be 180. Okay, so here this is OPQ is equal to OQP because this is an isosceles triangle. So 2 times OPQ plus 100 is equal to 180. Therefore 2 times OPQ is equal to 80. OPQ is equal to 40. So OPQ is equal to 40. Okay. Now take the big triangle, this one, RPQ. Okay. This angle we know is 50. This angle is 30, which is given. So 50 plus 30 plus this angle, which is equal to this 40 plus the required angle. Okay. All of this, when you add together, it should give you 180. So let's write down. So 50 plus 30 plus RPQ is equal to 180. So RPQ is equal to 100. But what is RPQ? RPO plus OPQ. And OPQ is 40 degree. Substitute here. So RPO is equal to 100 minus 40, that is 60 degrees. So in this sum, what we have done, first we have found out the value of this angle R. Then we have taken this triangle and we have found this value, which is 40 degree. Then we have taken this triangle and we have found this value. Okay, here we come to the end of the exercise. Please go through the exercise once again. Pause the video in each sum and practice them.